Okay, now in this one the first thing we've got to do is calculate the initial momentum, which is P. So that's just simply the mass times the velocity, which is 155 kgs, times 5.5 meters per second, and that's going to equal 852.5 kg meters per second. Oops, that's not right. And that's a total momentum. So after the collision, Jeff's car is moving at 3.5 meters per second. So that's 155 times 3.5. So I'll just do my calculator, times 3.5, and that equals 542.5 kgs meters per second. And there's different ways of doing this, but I'm just going to subtract these to get 310 kilogram meters per second. So that's a momentum that the other vehicle, which is Tom's, must have gained. So 185 times whatever that velocity is must equal that. So that's equals 1.67. So that's basically 310 divided by 185 equals the new velocity. So that equals 1.68 meters per second. And if we're doing two significant figures, that would be 1.7 meters per second, and that's going to the east as well. So that's the first calculation. Now if we carry on to the next one, Tom managed to work out from video that the collision will happen over 0.105 seconds. Okay. Now this is an explanation question, so it really doesn't need a calculation. However, just for the sake of looking at this, and it does come up in the next question, the change in momentum is 310. Okay, he still has 542.5 kilogram meters per second, so the change in momentum is that. So that's going to be 310 kilogram meters per second. Now, what this is getting to is that irrespective of whether the car is padded or not padded, or in these kind of collisions, and there can be different examples used, that the change in momentum, this stays the same. However, because the time is changing, if the time increases, then the force will decrease. Now that's using formula to explain things is a kind of key to getting a good mark on a question. So for this one, if it's padded, you'll just be describing how the padded collision kind of results in a longer impact time. And if that's the case and the time takes longer, and then you should also state that momentum, the change in momentum, is the same. Therefore, what's going to happen is the force will decrease in the collision where there is padding, because there will be padding or foam or whatever is involved, is the kind of delta t, the time for collision, has increased. Now you can also obviously do a calculation around this, which is kind of what's coming up anyway. So if we move up, we'll see that the one that's acting on Jeff's car, I'll just change colour pen to make it a little bit prettier, but the change in momentum is 310 kilogram meters per second. Now I've just written out the two cases. This is the one which involves the 0.105, and this is the one that involves a slightly longer time of 0.25. And you should be able to do a calculation to show how that kind of changes. If you get your calculator to work, and that's 2.95 newtons. Just a minute, that doesn't sound right. I think I just did that. 310 divided by 0.105 equal, okay, and that equals 2,952. And then if we do the other one, 310 divided by 0.25, that equals 1240. And we'd expect these to be different, and obviously that's newtons. And if we were to do two significant figures, that would be, well, that would actually end up being, that'd go up, that would be 3,000 newtons, wouldn't it? And this one would just be 1200 newtons if it was to 2SF. Okay, now, what force would act on Tom's car during the collision? Now, it's kind of a trick question in a way, because if force is acting, I suppose it depends on which collision you're talking about, but in either collision, if you've got force acting on one car, there'll be an equal and opposite force acting on the other. So it would still be, if it was this one we're talking about, it would be 3,000 newtons. So it would be the same force acting, but in the other direction. So that's question 1.